Hello everyone, today's lesson is about Introduction to Vibration. Do you guys know what is vibration? Vibration is any motion that repeats itself after an interval of time is called vibration of oscillation. Examples. First is plucking a guitar. Second is playing a seesaw. Third is riding a roller coaster. Fourth is moving fan. Examples of type of vibration system: slider crank, spring mechanism, spring mass system, and torsional system. Degree of freedom or DOF. Degree of freedom or DOF is the minimum number of independent coordinates required to specify completely the position of a dynamic system. Single degree of freedom is one displacement movement of a system. Then the other one is multiple degree of freedom, which consists more than one displacement movement. Classification of vibration. Free vibration is a system given initial force and moved by its own. For example, simple pendulum. Forced vibration is a system subjected to an external force, for example, vibration in diesel engine. Undamped vibration, no energy loss or dissipation in friction during oscillation. Damped vibration, occurrence of energy loss. Linear vibration, when all basic components of vibration system, for example, spring, mass, and damper, behave linearly. Non-linear vibration is any of the components behave non-linearly. Deterministic vibration, amplitude of excitation is predicted. Random vibration, the value of excitation at a given time cannot be predicted. Spring element. Spring element considered to have negligible mass and damping. In figure A, a coil spring has free length. Meanwhile, in figure B, when the spring is stretched, it will elongate. In figure C, spring gets shorter as the load applied to it. For the applied force, the linear force deflection model of a spring is F equals to Kx, where K equals to force over deflection. Potential energy done by a spring is equal to 1 over 2 Kx squared. Modeling of spring constant of a rod longitudinal vibration. Consider a uniform rod of length, cross-sectional area, and Young modulus subjected to an axial force. Recall the mechanics of material knowledge, write the formula of strain and stress. Substitute the strain into stress equation so that the new stress equation is written in the form of displacement and original length of the rod. Replace the stress with some representable or no term. Back to the original objective, which is to write down in the form of spring stiffness. F equals to Kx or K equals to F over X. From the equation, F equals to EAI delta or delta equals to Fi over AE, where give us K equals to F delta equivalent to EA over I. Modeling of spring constant of lateral beam privation. Find the equivalent spring constant of a cantilever beam subjected to a concentrated load at its end as shown in figure below. Spring in series and parallel. Finding the equivalent spring constant. Spring in parallel. From the figure shown, we can come up with equation K equilibrium equals to K1 plus K2 plus Kn. Spring in series. The total elongation delta SD equals to delta 1 plus delta 2. W equals to K1 delta 1. W equals to K2 delta 2. Thus, the series spring arrangement 1 over K equilibrium equals to 1 over K1 plus 1 over K2. Exercise for spring system. Let L equals to 0.5 meter for all figures under load F. The spring is extended having a length of 0.7 meter. Determine the value of X, value of K, and find the force needed to shorten the spring by 0.2 meters. The solution are X equals to 0.2 meter. Next, by using F equals to Kx, value of K is 250 Newton per meter. Lastly, the answer for the shortened spring force are 75 Newton per meter. A spring is pulled to 10 cm and held in place with a force of 500 Newton. What is the spring constant of the spring? The solution is given delta X equals to 0.1 meter, F equals to 500 Newton. Then we use F equals to K delta X. The answer is K equals to 5000 Newton meter. Fourier series. Periodic vibration system can be represented into harmonic components by: first, periodic function can be represented in the form of Fourier series. Second, Fourier series contain of infinite number of sine and cosine term. Xt equals to A0 over 2 plus A1 cos omega t plus A2 cos omega t plus B0 over 2 plus B1 cos omega t, or we can use Xt equals to A0 over 2 plus summation of An cos n omega t plus Bn sin n omega t. Meanwhile, as for the constant coefficient A and B, by integrating Xt, the answer will be A0 equals to omega over n times integrate Xt dt. Multiply the first equation by cosine omega t and integrate it for one cycle. We will get An pi over omega. We arrange the equation and we get An equals to omega pi limit t to t plus 2 pi over omega xt cos omega t dt. Next, to find Bn, we multiply the first equation by sine n omega t and integrate for one cycle. Next, to find Bn, we multiply the first equation by sine n the omega t and integrate for one cycle. We will get Bn pi over omega. By arranging the equation, we will get Bn equals to omega pi limit t to t plus 2 pi omega xt sin omega t dt. Simple harmonic motion. What is simple harmonic motion? A special type of periodic motion or oscillation where the restoring force is directly proportional to the displacement and act in direction opposite to that of displacement. Simple calculation. A simple harmonic motion has an amplitude of 0.3 cm and a period of 0.2 second. Determine the maximum velocity and acceleration. X equal to 0.3 cm, t equals to 0.2 second. Where we use f equals to 1 over t, we get f equals to 5 Hz. Omega equals to 2 pi f, then we get omega equals to 31.42 radian per second. X equals to x sine omega t, we differentiate to get velocity and acceleration. To find max velocity, x dot equals to omega x give us 0.0942 meter per second. And lastly, substitute into x double dot equals to negative omega square equals to 2.96 meter per second square. Thank you for watching.